Today we're going to do lecture 26. We're going to start talking about roundabouts today. We're continuing our discussions about at-grade intersections. And so we've gone through two-way stop intersections, any general at-grade intersections. We've already talked about how to do signalized intersection design with the vertical elements in that. Last time we were talking about sight distance, and again that was mostly at two-way stop intersections. That's the main case we're looking at there with our intersection sight distance requirements, and for both the left turn, the right turn, and crossing movements, and left turn from the main line. Through there, today we're going to do roundabouts. It's an element we haven't hit yet in our design. We won't go. Roundabouts are pretty complicated, so we're going to just talk about the general design considerations today. And things to keep in mind if you ever do design a roundabout, or what to look for in a roundabout. And we end back up on sight distance, so it kind of ties it back into what we just covered before. It's kind of our segue into it. We'll do a couple more lectures coming up on roundabouts so we get more in depth into that as we go. The main guide we use here in the U.S. is this NCHRP report 672. They call it Roundabouts, an informational guide. So you've got the green book, which is a suggested practice, basically, and which is not law, but it's suggested practice. This NCHR report is actually one level down from that even. It's just an informational guide. However, it's the only guide we have in the United States, or that's at least about the U.S. experience. We often borrow stuff from European models, looking at both quite often from England and sometimes from Australia. It's kind of the two competing main models we look at. And that's what has informed a lot of the stuff from the original, the first edition of this report. Since then, we've got more history with roundabouts in the United States, modern roundabouts, we should say, through there. And so that's what's involved inside this this informational guide now that we have through there. So even though it's not law, it's all we've got. And most agencies, NDOT in particular, if you were designing a roundabout, they would ask you to follow the guidelines inside of this report. And they've developed some of their own, in addition to that, are things that they're going to look for, especially about modeling and how to model the capacity at these intersections for that. So that's just to say, this is a free guide. You could download it and flip through it yourself. A lot of the slides today are coming from that, and the graphics are coming out of this through there. So again, we don't have a real a by-law design manual, but this is the best we've got, which is the second edition of the informational guide. Through that, what are some of the reasons we would want to use or not use roundabouts? So roundabouts is another tool in the toolbox. So if we have an at-grade intersection, as a designer, you'll look through that, or at least when you're doing the scoping reports, you'll look through the options and decide what's my best option for this location. Right. And it could be a two-way stop, a low volume, wide open space, plenty of sight distance. A two-way stop could be great, and that's all you need, and it's cheap. Right, those are cheap. Maybe it's a traffic signal, maybe it's a roundabout. So roundabouts don't fix everything. They're worse at some things. And stop signs, two-way stop in particular, and traffic signals are good at certain things, right? And it's just a matter of matching up which treatment is best for your location. And so that's why we're talking about roundabouts today, give you an idea what are the best treatments and what are the advantages and disadvantages using a roundabout. So where are they really useful for that? So in access management, sometimes we'll want to cut off. We've talked about before about the functional limits of an intersection, and we don't like having driveways within that functional limit. Or you may want to put a median down the center so that people can't cross in that area, which is safer and reduces conflicts. For that, one of the advantages of roundabouts, this top one here, is that if you've got a roundabout, people can come, or if you've got that median island, cutting off access to the far side of the road, people can't turn left and go into a driveway, say the McDonald's or something. They could go around the roundabout and come back over and get into it. So they could do a U-turn around that, right? So that's something that's usually either very hard to do at a traffic signal, or is not allowed to do a U-turn in the intersection at a traffic signal. But a roundabout, it's perfectly fine, and it's quite easy to do. U-turn that way and come back around. So I've seen it used a couple times in practice where that was a definite advantage, and that's one reason that was chosen. for that location was due to Roundabout, was to be able to provide that access for people coming back to the direction right through there. The environmental effects, it's probably generally they reduce delay, depends on your traffic counts. And that's, again, the elective class we'll teach in the fall. We learn about the traffic counts and how to analyze that and see what possible delay there is. Sometimes roundabouts are better, probably more often than not, that they reduce delay. And so that's a bonus for the environment. It's less pollution through there. Traffic calming, really, we using mini roundabouts, which is a whole different class, we use for traffic calming, right? A standard modern roundabout on, let's say, a state highway isn't a traffic calming device, really, through there. They will reduce speeds through the intersection, but in general, we use them for, number one, for safety, and number two, usually for efficiency. We're keeping traffic moving through that, through there. And yeah, one of the disadvantages is compared to some other treatments for traffic calming, these are more expensive, right? We talked before about a traffic signal. If you built a brand new signal with some added turn lanes and so forth coming into it and all that, you're probably in the $1.5 million range, plus or minus, $250,000 or $500,000 out of that. It just depends on your site. Right through there, roundabouts tend to be more expensive. There's a fair bit more approach work, especially on higher speed approach work coming into them. They've got this big island in the middle. Again, on a state route, it's going to be a fairly big island because you have to allow trucks or accommodate them well through there. Lots of drainage stuff through that. Roundabout, I'd say, is more in the $2.5 million range to get started. Again, at a kind of an average intersection, probably in a rural location, definitely in that $2.5 million range. Maybe in an urban environment where you have a tighter, smaller roundabout, you can get away with a little cheaper through that. This operation is maintenance one. People are always whining about, this was the big selling point of roundabouts when they first started getting built in the U.S. in the late 90s, was, there's no signal hardware. They're so much easier to operate. I'm here to tell you that the signals don't require that much maintenance. Every now and then someone clips off the traffic signal box. You have to go there twice a year to check the equipment in the cabinet. Otherwise, that's basically what you're checking, and make sure everything is still, all the signal heads are still attached to the wires. It's not that expensive. And they used to say, the operations costs are so much cheaper on a roundabout because you don't have electricity running all the time. Well, a standard traffic signal uses between $20 and $30 a month in electricity. You're not going to save that much with a roundabout. You definitely aren't. And not only that, but as time has moved on, we've decided that almost all roundabouts need lighted at night, need to have street lighting on them so you can see them well, and they're very conspicuous. Even big state highway rural ones have tons of street lights out there. Way more power being used there than running a traffic signal. So don't believe that. That's old story. Not really true. Aesthetics, they probably are prettier. And especially like if you've ever been out by Vail in Avon, Colorado, they were some of the first communities to use roundabouts in the 90s. Through there, they just overdid it, maybe, on aesthetics in the center. Lots of beautiful landscaping and statues and everything else in the center of their roundabouts. That's a lot of labor. That's a lot of cost put in there, but it's pretty. Yeah, I'll give you that. So that's a lot of people like them because they think it adds something to the community, which they do if they're well maintained. But that's a fair bit of maintenance that you're going to do. So you're not saving that maintenance cost off of that. What are some of the basic features of a roundabout? And there's a couple good videos here in your notes that are posted. These are clickable links, and so you can follow these links yourself and watch it in a better quality than what this is going to record it as. I'll probably play a little bit of this first one for you, but it's going to look better if you click it and watch it yourself on YouTube through there. But just to give you a basic idea, this is what a modern roundabout looks like. So there were an older version of roundabouts that actually started in the U.S. Back in the early 1900s, and they were just straight up circles with straight roads coming in, and they didn't when traffic got higher volumes and higher speeds, they didn't operate well, and we stopped using them in the States. And then it was in Great Britain and England, in the 1960s, they started working on putting in roundabouts again, and they refined the shapes, and that's what we call now a modern roundabout. So it's different than the old ones. through there. And so these modern roundabouts, some of the things to look for, the basic thing, the way we describe most generally, the roundabout is called the inscribed circle, which is the distance here at this circulatory roadway. This is called the circulatory roadway, going around from the outside edge of that travel lane to the far side on the outside edge. That would be considered the inscribed circle diameter. And that's how that's a quick way to gauge how big your roundabout is. And so people say, well, it's a 150-foot inscribed circle. And everyone's like, oh, okay. So you know what that means. And then you say, well, it's a 90-foot. Well, that's really tight. That's going to be a very slow roundabout right through there. 150, 180, you'll see that's more of a standard range for more of a rural roundabout through there. So that's the biggest measurement we use and way to describe roundabouts through there. Another thing to look for is we have these flared entries and we have these flared exits. You can see how the road comes in. It doesn't come just in straight. We flare out those lanes and we also taper back out like that. We also widen these lanes and we call that the taper through there, or the flare in that. So we'll flare out those lanes and they get wider through that. Then we taper back down to a standard lane. Those are all elements of the modern roundabout that we didn't used to use in the original ones through there. And the whole point of this modern roundabout is we're using geometry to control speed. And by controlling speed, we can make these safe and traffic flows smoothly and efficiently. So if you've already had the fluids class, right? We always like nice, smooth, laminar flow because it's more efficient. We're not wasting energy. It's similar in traffic, right? We don't want chaotic flow. We want nice, smooth, laminar flow. If we can slow people down to a consistent speed and try to keep it fairly consistent on all the approaches, then we can achieve that nice, smooth, fluid movement, and it's much safer as well as being more efficient, right, through that. So let's click on the link here. And we'll see if
the modern roundabout is a circular intersection with design features that promote safe and efficient traffic flow around a center island. Entering traffic goes through a curve that's sharp enough to slow vehicles to about 15 to 20 miles per hour, and drivers yield to the circulating traffic. Speeds are kept low because drivers have to go around the curves in a roundabout. Drivers approaching a roundabout reduce their speeds and look for vehicles already in the circle. After entering, drivers proceed to their exits. The overall result is slow and smooth movement. At traditional intersections, some of the most common crashes are right angle and left turn collisions. These can be severe because the vehicles often are going fast to make it through a green light. At roundabouts, these crashes essentially are eliminated because vehicles travel in the same direction and at slower speeds. Converting intersections to roundabouts reduces all crashes 40% and injury crashes 80%. There also are significant improvements in traffic flow, which lead to reduced emissions and fuel consumption. Roundabouts may be controversial when they're proposed, but public opinion changes once they're built. Motorists soon find out, through their own experience, the safety and traffic flow benefits, and then show enthusiastic support for roundabouts.
So you probably couldn't hear that really well. I forgot, since I'm recording this on the microphone wasn't near the speaker. So play that for yourself, and you could read the subtitles in there. So I guess it wasn't a total loss through that. It's just a real basic intro to it. Again, a lot of these videos came out in the early 2000s when roundabouts were very new and everyone's kind of afraid of them. So a lot of state DOTs would produce these videos as a way to inform the public what to expect and to kind of keep everybody calmer about them. So let's move on here. This is a little more detail in the roundabout and calling out all the different items. So we had this inscribed circle diameter right in here. Here's our circulatory roadway going around the center island, right through there. On our, excuse me, in our entrance, You can tell this gets a little bit wider in here. That's that flare. So we're flaring out, and then we're flaring this side and tapering it back down then to our initial lane or standard lane widths. Through there in the middle of the entry and the exit, we typically have a splitter island, and it depends a little bit on your location how big that splitter island is, both the width and how long the extent of it is. Through there, if you've got pedestrians, you're going to want to have a fairly wide piece right here, about 10 feet, so that pedestrians can have a good refuge. So again, that's one of the uses of an island, right? It was a refuge. Went through that a few lectures ago. So that's, and the 10 feet allows you to stop with a bicycle here in the middle as well and not have the wheels hanging out in either lane. On either side of it through there. On entry, we expect people to yield, and so we have an entry line here. A lot of times now we'll mark that, what they call shark's teeth symbols, which are little triangles, look kind of like yield signs. Again, and that's kind of a newer one. We didn't used to have a yield marker. It's been in the last 15 years or so. They added that as a pavement marking that people use. And getting the idea is to give you an idea that you're supposed to be yielding on entry here, right? If there's nobody coming, you can go ahead and enter through that. So the main concepts are, again, is we're using geometry to enforce the speed limit, basically, and the speed we want people to drive through the intersection. Right? It's hard to drive too much faster than that target speed. Now, if you get a multi-lane roundabout, yeah, you can. That one you can probably drive a little faster than our target speed is, but single lane ones are pretty good at holding people into a narrower range of speeds, and that's good. And that's good for safety, and that's good for traffic flow through there. We have lots of curvature. There's lots of curves coming into them typically, and we like to deflect those approaches. So you can't just come straight in at high speeds. You're going to have to deflect the vehicle. You're going to have to curve the vehicle a little bit to get around the center island. Through there. The one downside, for passenger cars, okay, that's great. We can get lots of deflection, but we still have to allow for big vehicles. We have to allow for the Indiana design vehicle, right? The WB67 coming through. It's going to have a much larger swept path, right? We've already shown how to look at radii right at the corners of intersection and how much space the truck wheels need, that swept path of the truck as it turns the corner. It's obviously this has a lot of corners in it, and particularly around the center island. So trucks are an issue, and for that we will build a special apron that the truck wheels can go up on, but we use a mountable curb, and then the truck wheels have this little paved center island piece in the middle that the trailer wheels in particular can ride up across. And so we make a very low curb, and we want it to be unpleasant so cars don't want to try to use it, but trucks are fine with it, and it's only about that 4-inch sloped curb, and it's pretty easy for a truck tire to come up across that. And we actually intend for trucks to use that and use that. And that's how we kind of can try to both design this for passenger cars and get the deflection we want, as well as still fit trucks through it. So that's kind of the trick that we use in that. All right, through there. In a multi-lane intersection, a roundabout, we would expect the trucks to hog both lanes. And sometimes passenger car drivers don't realize that. They think, well, why is he hogging up both lanes? Well, it's kind of built that way. So just note for yourself, never try to pass a truck in a double lane roundabout, right? The truck gets the whole thing when he's in the roundabout, and that's often by design. That's often expected through there. All right, so geometry also affects capacity. So the bigger the roundabout is, the higher the capacity is, but then the safety drops. And so there's always this real trade-off in roundabout design, which makes roundabouts an interesting one to work on, is because they're very iterative. You'll try something, you'll check the speeds, and then you'll realize there people can go too fast, so you change more than one of your curves, usually either the center diameter or one of the flares coming in, and the radii and one of the flares on the entrance for that, and you'll try to get that is goal, your speed goal, matched for what your roundabout should be. And we're going to talk here in a second about what our ideal speeds are within the roundabout itself, within the circulatory roadway. Right through there. And so it's just a lot of back and forth. You'll make some changes, you'll check it, you'll go back and make some more changes, you'll check it again. And roundabouts, more than any other intersection I've designed, is a lot of iteration. So they take a fair bit longer to design, according to me. And they've got better design guides now than back when I used to design them. But it's still, I think there's a fair bit of iteration to fine tune them and get them just right. There's a lot. It's a little bit more of an art form, maybe than some other intersection types. These are some of our standard sizes through here. Again, this is that inscribed circle diameter that we talked about. That's the main indicator of the size of your roundabout, right? So a mini roundabout, that's really just used in low volume, low speed situations in like a subdivision. Right through there, that's going to be these smaller ones, 45 to 90 foot diameters on that, right? Then the single lane ones, which is where we typically work, is this 90 to 180 feet range. And that's where we normally are for this WB67 right there, suggested 130 to 180. This would be on a state route because this is our design vehicle, right? That's what we're going to be designing for. And it can accommodate the WB67 using that truck apron and the inside. That's fine. But you're still going to end up with a larger inscribed circle diameter just to accommodate those trucks, right? When you get into multi-lane roundabouts, which is 2 circulatory lanes in the middle or 3 circulatory lanes in the middle, they get much bigger. Right, and we still get pretty good efficiencies in multi-lane roundabouts. Not quite as, you don't get twice as much efficiency as you would with a single lane, or 3 times as much through there. Nor do you get, 2 or 3 times the capacity if you add a second or a third lane on any roadway through there. It's not. It's not equal. Right? Each lane isn't equal. Then ones you add next don't have quite that as much capacity as the original one did. Through there, the problem with these was they get this bigger, especially as you get over 200 feet, is your safety is going to drop because people can cut through them faster. And you're going to see that here in a second when we talk about fastest path through there. And in a mini lane, you're probably not going to see very many of these. You're not going to be asked to design very many mini roundabouts. There's a little less effort put into designing a mini roundabout. Most of your work is going to be probably the single lane and then some multi-lane roundabouts. I would guess, 80%, 70 to 80% of the roundabouts being built are single lane with an occasional, bypass lane or something extra. So think about Sturdy and LaPorte. Just out by campus there, that's a single lane roundabout. The new Silhavy one is a multi-lane roundabout through there. But thinking about all the roundabouts in Valpo, right, we may only have 2 multi-lane roundabouts. The rest are all single lane. And that's pretty common across the U.S. Through there. And so our speed range, what we're aiming for is 20 to 25 miles per hour. If you can keep people at that speed within the circulatory roadway, it's going to work pretty well. Unless you screw something else up on the entry, but generally that's our target. If we can keep our speeds within that range, it's going to be safe and it's going to be fairly efficient, right? For multi-lane, we have to live with the fact it's going to be a little bit faster roundabout, and we're going to lose a little bit of the safety bonus for that. Still better than a traffic signal in general. Right, still better in almost always than a traffic signal. And then here's some of our max for a single lane, max number of vehicles per day that can pass through it. It's about 25,000 for a single lane roundabout, about 45,000 for a multi-lane roundabout. And that's why you would jump up to a multi-lane, is just because you need that capacity. You've got that much traffic out there. One other thing to think about in roundabout design is compared to a traffic signal, their footprint is very different, which is, pretty obvious right here at the circle, right? Here at the roundabout, it's going to be pretty obvious. You all have driven through the roundabouts here near campus, and they're really big right here at the node where the 2 roads intersect, right? Through that, and people say, well, they take up so much space. That's awful. The point is, from this slide, is this blue area is the extra space you would need for a traffic signal. You can see in the background here would be, in this gray color, is the footprint you'd have for a traffic signal. Well, we often have to add auxiliary lanes, which we learned about last time. You often have to add these auxiliary lanes in here, and that adds up, that takes the space up. So that's this blue area that we're adding into it. Right. The roundabout does need more area in places, but it's almost always near the nodes. Right. And so on a traffic signal intersection or signalized intersection, you're using a lot more right of way, a lot more space area coming in on the approaches along the links and not as much at the intersection itself. In a roundabout, you use most of the extra space you need at the node, at the low intersection, and not further out. So you can have narrow links and then wide nodes through there. So that's one of the things you'll hear about roundabouts. And in some states, for a busy enough intersection that would be a fairly big signal, it's been shown that you'd actually use more, you'd need more new area for all this widening of auxiliary lanes than you actually would from a roundabout at that. Or sometimes it kind of comes out even through there. It's just where you need it is different. So a very tight urban intersection, roundabout is not always, often not a good choice because of that need of space right at the intersection through that. If it's a little more of an open intersection, then you can probably get a roundabout to work pretty well there and actually save right away, further away on the approaches coming through that. Right. So another, how you line up the entry roads and in comparison to the center of the inscribed circle diameter is an interesting piece right through here. And so we've got options. This is called a left offset one. And so this entry approach is to the left. You can see this dotted line is the center line of the entry road here, is to the left of the center of the circle. And what's good about this is this has a lot of deflection for incoming vehicles and will really slow people down as they come in. The bad thing about this is, assume you have a road on this side, as people exit, it's a pretty straight exit and they may be hitting the gas and you'll have higher speed exits coming out. And then if you've got a crosswalk right here, that could be a problem, right? Through there. This would be a centered one, and so you're coming in. It's kind of the balanced approach. You don't have as much deflection coming in, so it's going to be a little bit harder to slow vehicles down so that they're going at 20 to 25 miles per hour. You want them to be up here in an inscribed circle, right? But now you're also not letting them, from this point out, just hit the gas and accelerate and take a really fast exit out of the roundabout. They still have some deflection here, so they're going to slow down as they come through that. And then the final one is offsetting to the right. And so now this one, we tend not to do this one if we can, right? Because this is not much deflection and we're worried. One of the things we're a little more worried about is that entrance speed. We really want to keep that down and get people to slow down before they enter the circle and not slow down too late once they're in it. Right through there, but it does have good deflection on the way out, so you're not going to be hitting the gas too hard until you've come through this last curve, and then you'll accelerate and move on out right through there. The angles, one thing to look at was we have perpendicular legs, or if you want to offset these a little bit, this would be centered approaches on all three sides through that. What we're looking at, these dark lines are these vehicle paths. This is the path a vehicle could use. And you're going to see this a lot more in a second when we talk about fastest paths. That's what they're actually showing here, right? If you hug the center line here and then come through the circle and then you're close to the center island, but then out here on this radius point, you're back far out again, and then you're back to the center. That gives you the smoothest line through here and would be the fastest path. And so this is how you arrange these approaches and offset them or not, and the angle between them is going to affect what these paths are, right? And you have to check all of them. You have to check every single path. It is time consuming. Right, through here. So just keep that in mind. Yeah, maybe it works out really well to have an odd angle coming in here, but you'd have to check that one too for what its path would look like and make sure it's not too fast, right? And that's what the problem here is. These are, some people thought, well, every time I've got more than two roads crossing, I'm just going to throw a roundabout in there because I can always get a roundabout to fit. But then you get into trouble that maybe your angle between them isn't high enough. And like here, this is a pretty fast path, right? And people can really cut through here fast just because these angles for the entrance road versus the exit road here, that's what, 120 degrees, that is just not a good angle. And people can go really fast through that. Right, so we've got to be careful about all those entrances and exits through that. And that brings us to fastest path. And so that's what we're going to check for. And this is right from the guide through that. And for each of these colors is a different movement, right? So this is a straight through movement. Here's a left turn movement in the red. And then here in the green is a right turn movement through that. For each one of those, you have to check the radius of each part of that. Right, and there's an inflection point, and there's another radius, an inflection point, and then another radius through here. Each of those R1, R2, R3, they're probably not the same, almost never are. We often draw like a spline curve through here and match that up really nice and make it nice and smooth to try to approximate what we think the vehicle's path would be. And then we'll snap in and figure out what the radii are in that. And then we'll check those radii versus what we would versus a chart that suggests what speed people will be going if you have that radius right through there. And again, we want to keep it in that 25 mile per hour range. That's our goal, 20 to 25 as it comes through. We don't want any radius on here allowing people to go over 25 in a single lane roundabout. That's our goal. Through that, and you have to check every single path, right? So here's the through, the left, and the right. Well, that doesn't look too bad, except you have to do the through, the left, and the right for each approach, right? So that's 12 in this case. So that's it's a little different on that. So this is a better diagram. This is how we would draw it, and like I say, often we used to use a spline curve to pass through these points. Through there, and you'd spend a fair bit of time trying to make them nice and smooth through that. And this is from the guide. They suggest that at the beginning, you'll start 3 feet, the center of the vehicle will be 3 feet off of the inside striped line of that lane. Right. So that car is hugging that inside line. Because this is they're like a race car driver. They're trying to get through this curve as fast as possible. So they hug this side. They come out here. They'll get about 5 feet from the edge of pavement. People are a little more worried about hitting the edge here. And there's usually curb there, and that scares them through there. And it's the far side of the vehicle from the driver. And then here, they'll be 5 feet off that island, then 5 feet here, and then back to 3 feet here, because this is just a striped line. They'll get closer to a striped line than they will a hard object. Through that. So if you can maintain those offsets through there and use that as your closest approaches in each location, that'll give you, and then make a nice smooth line through it. That's your fastest path. You'll then come back and find what the radii at different points are along that line, and then you'll check that against your design speed. All right. And this is the chart we use for that. And so this is down here is this super elevation rate, but the basic one here is if we went back here, if this curve right here, maybe that's R1, is 50 feet radius, we'll come up here 50 feet, people were driving in a range of 15 to 17 miles per hour. Okay, well, that's slow. It's not terrible, but it might be better if we were up closer around 100 feet, because that's our 20 miles per hour right through there. And here's our super elevation, and the point is when we design these coming in, usually this roadway, this edge here is lower than that, so we're sloped outwards. So you've got a positive super elevation coming through that. But as you come around this curve, you're turning left, but the road is still usually falling to the outside. Not always. You don't have to do it that way, but usually it is, and it's falling outside. So that's a negative super elevation, and you come back to a positive super elevation. So in that center curve radius, you'd be using this negative line. So at 100 feet at a -2, you're going to be going a little bit slower. You're going to be going more 18. If you had a super elevation was helping you, like on the entrance, at the same radius, you'd be going 21, 22. So a little bit of difference there, and that's why we throw these in here. This gives you that range. That's typically we try to be careful not to use too much super elevation in a roundabout, because trucks have trouble with that. All right, the max is 4%, so never have more than a tipping, what would be a negative super elevation rate of 4%, or you may lose some trucks. The trailers will tip over. So, and we like to be near this 2%, and yeah. Okay, occasionally you can go a little higher than that, but we try not to, right? So here's our target ranges. We're at 20 to 25 miles per hour. You're going to be, 90 up to a little over 200-foot radius through there. So that's the range of radii that we're probably going to try to get that fastest path to stay within. That's our boundaries for that fastest path. The last thing we want to look at is sight distance, right? And how does that apply to a roundabout? So we've understand now some of the basic concepts with the roundabout. And now let's apply it to what we learned last time, which was about sight distance through there. And what we're looking at is on the approach, we just need stopping sight distance. On the approaches coming in, these vehicles need to be able to stop in time. And if you have a crosswalk, they have to be able to see the crosswalk. So if there's someone in it, they can stop in time. And if there is no crosswalk, then you're only caring about this yield line. They'll need to be able to see it and know that they have to stop there within stopping sight distance for that, whatever this approach speed is back here. And so then that'll be our point that we'll measure to. And we actually measure stopping sight distance, along the center of the lane. So if you measured here, this is the line of sight. Do that. The gray area in these next few slides is the area that has to be free of obstructions so that the vehicles can see. All right, through that. So that's what the gray means along this. The dotted line is the line of sight. And so that's the boundary of that gray area that needs to be clear of any obstructions so the driver can see through that. If you're coming around the circle in a roundabout and you describe circle this way, right, you still need to be able to see in front of you enough distance so that you can stop in time. So it's still stopping sight distance, but you're measuring along this arc through here, but here's your sight line. All right, and so that needs to be clear of any obstruction that will block you from being able to see any obstruction in the path of your vehicle as you come around this inscribed circle through there. So people who want to put great big fountains and landscaping in the middle, that's fine. Just you can't be inside this dotted line. You have to be over on this side. And then what you do is you actually move this vehicle from there to there, and you just kind of rotate it all the way around. You'll end up with a little circle here in the middle of places where you can put really big stuff that we don't need for sight distance through there. But you have to plot all those sight distance envelopes first to get that in. So here's on approach, cars coming in and looking, they have to be able to see the exit, and particularly the crosswalk and the exit. So if that's within if it's a really big inscribed circle, a very large roundabout, multi-lane, right, their stopping sight distance may be back in here. But if it's a smaller one, that crosswalk is within that sight distance. So if no one was coming and they rolled right through here at 20, 25 miles per hour, right, they need to be able to see this way far enough so that they can stop in time before they get there. Couple more diagrams on entry. So we don't want people to have to stop at the yield line here, right, and wait and then look. Right, we don't want that. Now I'll talk about a little odd case here and stop in sight distance in a second. But about 50 feet back, we want people to be able to start making a decision about can I go or can I not go. Right, so that they don't have to come to a full stop. And that's like that yield condition we talked about yesterday, last time, in the intersection approach, right? And so this is the same. This is a case where we actually are using the yield condition for that. So this vehicle, this driver is looking, and they need to be able to see everything along this path far enough back to make an appropriate decision about whether to go or to stop. And so you've got to check both people coming around the circle and people entering from the nearest upstream exit, or entrance, nearest upstream entrance coming in through that. And they need to be able to see back far enough along both of those paths to whatever the required distance is to make a safe judgment on whether they need to stop or not. Now, as they come in this 50 feet away, they should be going fairly slow because of this curvature and because they know they're approaching a roundabout. And then they start looking to see if they can go or if they have to come to a complete stop. So they're rolling fairly slow at this point, we hope, all right, through that. And this is that rare case where you're going to use that yield condition, which last time I told you we rarely ever use. Well, roundabouts we do. We do actually do, because it is a yield condition. This is a little more complicated sketch showing all of these sight distance parameters, and all this gray area is the area that can't have anything in the middle. All right, through here. Like for this, if a car is a multi-lane entrance, it's a more complicated roundabout, car is sitting here, they have to be able to see to the crosswalk. All right, so this gray area, nothing can be in there. All right, a car as it's approaching the yield line, they need to be able to, this car is approaching in this direction. He's coming up in this lane. He needs to be able to see upstream. We just looked at that case, so he needs to be able to see upstream there. He needs to be able to see upstream around the inscribed circle. So that's his 2 sight lines, looking those 2 directions and so forth. So it looks complicated, but as you see these orange lines, you can kind of match it up to which vehicle it is that is needs to be looking that direction, right, through there. In the end, all these gray areas, you have to, grass is fine, but you can't have anything, too tall that's going to obstruct view. A bigger roundabout, you'd have a spot here in the center that you can actually put taller stuff into. All right, so that's the talk today on roundabouts and sight distance through there. And one thing, let's go back. Second, this one interesting thing in roundabouts they found in other countries, which we've now adopted here in the U.S., is if people can see the approach and see approaching cars from too far back, like a couple 100 feet back, they'll make poor decisions. And so there is a case where sometimes we'll actually plant shrubs right along that line and over on this side to block people's view until they get closer to the roundabout. Because if you can see too far back, you're going to try to approach here too fast. You're not going to slow down enough. And then you may make a bad decision because you're going so fast as to whether you can yield or not. Or by the time you realize you need to yield, it's too late and you can't. Right through there. So we actually, by blocking people's vision until they get, within this 50, 60 feet of the yield line, it'll force people to slow down. Okay, I know, but I can't see it. So I'm slowing down. Then I'm looking, okay, now I can see, but now I'm also going slow enough. I can make good decisions and come through there. So that's an interesting thing where you can actually have too much sight distance, something we've never heard before. All right. In a roundabout, there is a case where you can have too much sight distance. It leads to people being a little bit too fast and making poor decisions through that. Okay, that's it for this time.